So in today's class we have a review of the discussions held during the last 1 month, that is from 1st July to till date. Okay. So in this month we have interacted various chapters in plastics forming techniques and also finishing processes and metrology. Like this, various chapters of advanced manufacturing engineering has been dealt. Okay. Today we will see how these chapters will influence the production agencies, or you can say industries, in practical approach. Okay. Suppose in the first week of the July month we discussed about some metrology chapter where we also learned that metrology is a science of measurements. Okay. As you know well, measurements are of three kinds, or you can say measurements will be different types. Out of those different types of measurements, prominently used measurements in the manufacturing industry are linear measurements and angular measurements and surface measurements. So these topics have been explained in detail how linear measurements can be measured and also how angular measurements can be measured and also surface measurements. So in metrology chapter, so it's all about measuring the measurements. In another words, metrology is nothing but the science of measurements. So as you know, for measuring the different measurements, we have various typical instruments and various sophisticated you can say equipment that can be used to measure the very intricate and non-precision measurements. All these topics we have dealt with in the first week of July. Okay. So in today's class, I will brief you what we have learnt in the entire month of July, right from the 1st July to till date. That means 30th July. That means today. So measurements, as you know, linear measurements that can be measured with a simple steel rule, and also we have angular measurements that can be measured with some specific instruments. As you know, these instruments in day-to-day practice, they will have a place in your compass box, like bevel protractor, angle protractor, angle gauges. Okay. As I said, in the first week of July, when I am dealing with measurements or when I am explaining metrology chapter, I also briefed about the various angular measurement instruments such as bevel protractor, sine bar, angle gauges and slip gauges. Okay. Out of this all angular measurement instruments, out of this all angular measurement instruments, you will find a typical instrument called sine bar. So as I explained in the first week of July, sine bar by its constructional details, it will have the shape of in the inclined shape. It has upper rollers and lower rollers. Okay. Then whatever the slip gauges available with our industry, as you know, slip gauges are manufactured in a section in the industry. If you take any industry, as I already told you, there is a separate section for manufacturing the slip gauges. That section is known as tool room section. So in the tool room section, you will find you will manufacture all the slip gauges. So the slip gauges thickness vary from 1 mm to around 12 mm, 20 mm, like that. So whatever the manufactured slip gauges readily available with the tool room section, those will be taken and they are kept on one another in such a manner that one slip gauge of 2 mm thickness is kept alongside the sign bar, and above the 2 mm thickness we will keep the 4 mm thickness slip gauge, and above the 4 mm slip gauge we will keep the some 6 mm slip gauge. So these, and above 6 mm slip gauge we will keep the 8 mm slip gauge. So these 4 slip gauges will consist a set of slip gauges. Okay. Then when it comes to the set of slip gauges 2 mm, 4 mm, 6 mm and 8 mm, if you go on placing one over the other the slip gauges, finally one slip gauge will touch the upper roller of the sign bar, as I explained in the first week of July. Okay. So when the upper roller of the slip sign bar will have the contact with the final slip, topmost slip gauge, then we will count the how many slip gauges are required to have the contact of the upper rollers of the sign bar. Let us assume that 2468 is a set of slip gauges, another 2468 is a set of slip gauges. That means here 2468, that means 246 again 612, 8 is 20. That is, this is one set of strip gauges. Again 2, 4, 6, 8, another set of strip gauges. It means 20 plus 20. That means topmost strip gauge is having the 8 thickness, which will touch the rollers of the topmost rollers of the slip. What you can say, sine bar. Okay. That means the 40 thickness, 40 height, they will have the upper rollers. So this 40 height will be earmarked as H. Then, as I said in the first week of July, the distance between the two rollers, upper rollers and the lower rollers, okay, these will be measured, and this can be the distance between the two rollers, that is designated as a capital D. Okay. So if you draw a parallel line with the axis of the lower rollers, you will find the angle between the lower rollers and the parallel line along the axis of the lower rollers. That angle is theta. If you take sin theta is nothing but the height by hypotenuse. Height by hypotenuse. Height is h, as you know, that is 40 mm. Hypotenuse is distance between the rollers, that may be 80 mm. So obviously it is equal to 1 by 2. So sin theta is equal to 1 by 2. When sin theta is equal to 1 by 2, then the theta will become sin 30. So the angle between the lower rollers and the parallel line drawn to the lower rollers is known as 30 degrees. This is the reason the instrument is named after the sine bar, because we are using the sin theta to calculate the measurement of angular measurements. So hence the theta, sin theta is coming into the picture, then instrument is named after the sine bar. So with reference to angular measurements, sine bar is of most important measuring instrument, and it will frequently appear in the end examination, as I told you, in the first week of July 2020. Okay. Then we will switch over to the surface measuring instruments. As I told you in the previous classes, while dealing with the metrology chapter, there are many surface measuring instruments like optical flat, interferometer, etc. Out of all these angular measurement instruments, we can say that the most widely used instrument is optical flat. As I said in the first week of July, Optical flat utilizes the light waves. That means there will be a light source. From that light source, as I said earlier, light waves will travel through the object and they will get reflected back into the space by making an angle with the surface of the object. If the angle made with the surface of the object is low, then it is called the surface is said to be free of defects, blowholes, surface defects, etc. If at all the light waves that will travel through the surface of the object and revert back into the space by making a wide angle, then we can assume that the surface is having some defects like cracks and surface defects like we can say small blowholes, etc. As I told you in the month of first week of July. So this is all about the brief description about optical flat, which is very well known to you. This is all about the optical flat, which is very well known to you, as I explained in the first week of July with regard to Metrology chapter. If you want to measure the surface roughness of a given object. Okay. And also in metrology we dealt with the various comparators, okay. That means if you have a standard measurement fixed by American Society of Engineers or ASME, American Society of Mechanical Engineers, but if you measure the given length or given any dimension, the instrument is showing only a little lesser amount than the standard amount, then it is called what we can say, that is what we can say is this particular instrument is having some defect and it is showing some error. Okay. So what I mean to say is, comparators obviously they will measure the known value, they will measure the given value, that given value is also termed as the known value. This known value is compared with the standard value. If the standard value is 100 mm, but by measuring the given measurement with the comparators, if you are only measuring 99 mm or 98 mm, this is the known value. If you compare these two measurements, you will find a slight difference, maybe 1 mm or 2 mm, then we can say that that particular comparator is showing the error in the reading. So the basic purpose of comparators is nothing but the comparing the known value with the standard value, thereby evaluating the deviation in the measurements. Okay, so this is the basic function of a comparator. Again, in the first week of July, I also explained you types of comparators. Okay, optical comparators, pneumatic comparators, electrical comparators, like that various comparators I also explained you. Okay, whatever the comparator it may be, the main function of the comparator, I told you that it is to compare the known value with the standard value. Okay, then again see, here we will find some difference in the measurements, then we will have a doubt in our mind that why this difference is coming when compared to the standard measurement. So this can be efficiently dealt with a technique called calibration. So in the first week of July 2020, so when I started video lessons in the first week of July, I was referring to Metrology chapter. Calibration is a process of measuring the, or you can say calibration is measurement of measuring instruments. This is what I told you in the previous classes. Measurement of measuring instruments. So what is the need to go for measurement of measuring instruments? Why? Because if you take measuring instruments like steel rule, or you can say you will have a tape, a construction industry technician, you will use tape for measuring the length. A steel rule, mechanical steel rule, or any other instrument, over a period of time, that means for a period of 1 year or 2 years, what will happen? These instruments, over a period of 1 year or 2 years, what will happen? These instruments, they will lose its accuracy and precision, and also continuously they are exposed to the atmosphere, so that the corrosion and wear and tear will take place on the measuring instruments. So to minimize these effects or to eliminate these effects, what we will do is we will go for the measurement of measuring instruments. So already steel rule is a measuring instrument and our tape is a measuring instrument. In your day to day class, in your what you can say, um, this protractor is a measuring instrument, drafter is a measuring instrument. But over a period of time, if you continuously use the drafter, what will happen? So it will give you wrong results, wrong readings because of wear and tear and continuously exposure to the atmosphere. They will get rusted. Okay. So that is the reason we will go for the calibration technique. That means we will measure the measuring instrument. So if the measuring instrument, if you use the same measuring instrument after 5 years for measuring the value of 100 mm, it will show only 98 mm or 94 mm, 95 mm instead of 100 mm. So there will be error in reading. So to eliminate that error or to minimize that error, what we will do is we will go for the testing of that measuring instrument. We will measure the measuring instrument. If it is not giving the correct reading, then we will replace the measuring instrument with a new instrument so that readings will be taken perfect and the construction or the you can say the wherever the reading is required, that is up to the mark. This is also I explained in the first week of July when I was dealing with the metrology chapter. That is about calibration. Okay. So again in metrology chapter, apart from calibration, I also explained why, even though all these instruments we are having, like linear measuring instruments and angular measuring instruments, surface roughness measuring instruments. So in spite of having all these measuring instruments, again there is a scope, there is a necessity to go for the another precision instruments. Okay, which will not be measured by these conventional measuring instruments. Okay, those instruments also we dealt in the first week of July. Okay, then after completing the metrology chapter, then we switch over to another chapter. Okay, that is about finishing processes. Finishing process. Okay. So finishing processes, in this chapter we have discussed in the second week of July, we will have various finishing processes. Okay. All the finishing processes aim at the surface finish of a given object should be up to the mark of point not 1 mm. That means, so whatever the finishing process you take, the surface finish should be utmost quality. So it should serve the purpose of the industrial need as desired. So in this finishing process, we have discussed about various finishing processes. So various finishing processes what we discussed are like, we can say, electroplating, then we can have some other finishing process. Okay. And mechanical finishing process, pneumatic finishing process. Okay. So like this finishing process have the vital role in getting the good quality surface finish of the given object. Okay. So this is all about the finishing process what we have dealt in the second and third week of the July 2020. And also I have given an separate and also I have given a separate session on finishing processes, a small answer small question and answer session on finishing process, and also essay type question and answer session on finishing process, so that you will be acquainted with the which type of questions will be asked in the end examination. I also briefly explained how to tackle the questions and how to write the answer in an appropriate way. So for writing the answer for the given question in a suitable manner, that has been explained in brief, so that you will have the proper understanding of the writing the answer with reference to the finishing process. Okay. So this is all we dealt with the second week of July 2020. So then in the third week of July 2020, we switched over to plastics farming, plastic processing chapter in our subject called Advanced Manufacturing Techniques. So, as you know, plastics processing involves, as I explained in the third week and fourth week of July, plastics processing may be done in two categories. The first category is process techniques. Okay, the second category is farming techniques. As you know very well, the process techniques, we will find the various processes like molding process. In those molding processes, we will have injection molding, transfer molding, blow molding, etc. So, whatever the process technique that we adopt for processing the given plastic, so that finally the plastic will take the required shape as per the industrial need. That is all about the process techniques. And if you go for plastics farming techniques, again you will find two more important techniques. Those are plastics extrusion. So, for the last 4 to 5 classes, I have been continuously concentrating on plastics farming techniques, that too on extrusion process, where a molten metal is fed into the chamber. The chamber will have a orifice. Through that orifice, with high pressure, molten metal will come out, and that product will be taken out, and the same is passed into the different, we can say, strips or conveyor belt, so that the plastic, after solidification, it can be cut into our desired length as per the industrial requirement. So, this is, I am continuously repeating about the extrusion of plastics. This extrusion of plastics will definitely find a place as a question the end examination. That is the reason I have been continuously focusing on this plastics forming technique called extrusion. Okay. Then we also have another plastics forming technique that is known as a sheet forming. In the sheet forming, in the last 3 to 4 classes, I explained you a plastic sheet has been fed into the two rollers which are rotating in different directions. Okay. If one roller is rotating in clockwise direction, another roller is rotating in anti-clockwise direction. So that the strip of the plastic will be pressed and it will become very thin plastic sheet. Then if required, the same plastic sheet will be fed into the another set of rollers so that the least thickness of 0.03 to 1 mm can be obtained through this plastic forming technique called sheet forming. Especially this sheet forming is used for those articles is like needles and hollow objects, as I told in the last 4 to 5 classes. So needle, if you want to manufacture, it is very thin. You cannot manufacture a needle which is used on a tailoring machine for stitching the cloths. Okay. This particular needle you cannot manufacture with another technique because this requires a sophisticated surface roughness finish and a precision tools. Much advanced equipment are needed for manufacturing this very low thickness objects like needle, and also sheet forming will be used for producing hollowed objects. Here comes a question, as I told in the last 1 or 2 previous classes. Hollowed object means in our day-to-day life we are using, suppose, a funnel for pouring the kerosene into our desired dish. Okay, that particular funnel is made of, you can say, only with the help of this sheet forming techniques. And also you can take the examples of the plastic bowls. Okay. Especially in kitchen utensils, you will find the best examples for sheet forming techniques. Okay. If you have the plastic bucket, mug, another plastic utensils in the kitchen, especially these are manufactured with the help of sheet forming techniques, as I explained in the last 2 to 3 classes. So this is all about the plastics processing techniques. So apart from these two extrusion and sheet forming techniques, I also explained in detail about vacuum forming and air pressure forming. These are also used for producing sound quality objects. Okay. So plastics with sound quality are produced with the help of vacuum forming and high air pressure forming techniques. So this is all what I briefed in the last 1 or 2 classes. Okay. Now today I am reminding you all the lessons or all the lectures what I delivered throughout the month of July, so that you need not forget those lectures, and you should be keep in mind the important points, important topics, important diagrams, and important features that will frequently appear in the end examination. Okay. And also apart from plastics processing techniques, I also gave you small question answer session on the plastics processing techniques. Also essay type question answer session on the plastics processing chapter. Okay. So all these chapters like plastics processing, finishing process, metrology. Okay. If you take all the chapters, one common thing you will find in the all the chapters. In all the chapters, the common thing is that converting our raw material into desired product with the given dimensions. Whatever the chapter you take, in our subject advanced manufacturing engineering, whatever the chapter you take, it may be plastics processing, metrology, finishing process, and other chapters also there. We have 6 chapters in our advanced manufacturing engineering subject. Out of 6 chapters, I briefed you 3 chapters. If you take any chapter or topic, what we will find the common between all these chapters is that converting the given object, given workpiece, or converting the raw material, given raw material into the finished product. So whatever the technique you will follow, that doesn't matter, but our aim is to convert the given product or given raw material into the finished product. Okay, so this is all about the advanced manufacturing engineering, whatever we have learnt throughout the month of July 2020. Okay, I hope you all are satisfied with the lectures delivered by me, and also I raised the questions which are igniting your minds in my lectures. The answers also were given by me. Okay, because in this video lectures, as a lecturer, as a faculty, I cannot directly interact with the students. I have to assume that there are 40 to 50 students before me, and then I proceed to deliver the lecture. While delivering my lecture on a particular topic, so in between the topic, students will come across with several doubts. So those doubts also were raised by myself and also answered by myself. Because when I deliver my lecture, I'll give you the lecture in the perspective of students' mind, and then the lecture will be slowly progressed so that it will be, and the lecture will be slowly progressed so that it will be easily understood by the student community if they listen my video lessons concentrately, so that they have the sound knowledge of whatever the topics I have dealt till now from the 1st July to the 30th July. Okay. So my intention is to absorb as much knowledge as you can with these video lessons, because for recording a 1 hour video lesson I have to go through the various reference books for a particular chapter or for a particular topic. Why? Because if I am dealing with the optical flat, there may be several doubts in the student's mind. Even though there are no students in front of me, and that also will be taken care of by me, and that will be addressed by me also. So in this way, all the video lessons delivered by me will be useful to the student community, because I will deliver the lessons, video lessons in the student's perspective, even though students are not before me. I'll assume that students are before me, and if I am delivering a particular topic, they will come across with such doubts. Those doubts also I will raise in the video lesson, and I will clear those doubts also. So this is my way of delivering the video lesson. Okay. So as today is the last day for the video lessons, so I think I feel privileged to have been associated for doing this grateful job of video lessons, and I am extremely happy in one way that from the day one when I started my video lesson, I was little bit embarrassed while recording my video lesson, but on a particular topic. But while the time passes, or while the days are increasing, definitely I find pleasure in recording my video lessons and delivering my video lessons. Okay. So in this way, I am very much thankful to our Honorable Commissioner for assigning this much benefited task to the faculty for improving the lesson delivering skills, and also to acquainted with the latest technology during this lockdown period. Okay, thank you very much.